Yo, what's going on? Hope everyone's doing well today. I'm going to demo a simple zero-knowledge proof that I built using the Circom language for arithmetic circuit compilation and SnarkJS, which is a library off of Circom for these zkSNARKs. Now, I just said a bunch of words, so you might be kind of unfamiliar with a few of those concepts. So to get a base level understanding, link in bio, you can read my 2 Medium articles, one of them delineating what zero-knowledge proofs are in general, and the other one specifically about this project with a detailed code breakdown and explaining a lot of the more complex topics I don't get into in this video. So definitely go check those out, and let's get into this. So in the simplest way possible, zero-knowledge proofs allows the prover to prove something to a verifier without actually giving details about what they're trying to prove. In the context of zkSNARKs, for example, this entails if someone sends a transaction of, let's say, 10 ETH to another person, this zkSNARK has to check that that person actually has 10 ETH to send, but without actually knowing who the person is or how much is in their wallet. So you can use a mathematical circuit to prove that something is true without knowing any details. But again, if you want to learn more, link in bio, you can read up about the ABCs to ZKPs. For zero-knowledge proof to take place, there need to be 3 parameters it needs to hit. The first is completeness, basically meaning that if the proof is true, then the code will run. Then there's soundness. Soundness is the parameter that entails if the proof is invalid or false, then the code does not run. And the third one is zero-knowledgeness, which is basically ensuring that the prover's private information is not known by the verifier. So we're going to follow 5 steps to get this Circom zero-knowledge proof done. Step 1 is to design our arithmetic circuit using the language Circom, of which I will show you in a second. Next, we have to compile the circuit to get our low-level R1 constraint systems, which are just mathematical equations, very complex mathematical equations, to create the proof. And then we will use SnarkJS to compute our witness. I'll explain this in a second. We'll generate a trusted setup and get our proof. And then we will validate our proof within the compiler. So let's talk about step 1, creating the arithmetic circuit. For arithmetic circuits in this specific zero-knowledge proof called a zkSNARK, all the constraints have to be in the form of A times B plus C. This simple mathematical operation will allow for the proof to be created. zkSNARKs are non-interactive zero-knowledge proofs, which work really well with Ethereum because they allow smart contracts to verify the proofs. So if a proof is valid, then a certain function in the smart contract can run. Within the zkSNARK, like we just talked about, we have our input values split up into signals. And the input values are input signals, so your A, B, and C. And then the intermediate signal is that D value that we just talked about. And then of course your output is your output. These equations are what we call constraints. And the simplest form of a constraint, which is this form, is an R1CS constraint, which is a rank 1 constraint system. Oftentimes, one of those input values is the private key where everything else is public. And that input value is something that we don't want the verifier to know. But the other values we keep as public so the verifier can know them, and the goal is that we can still have the proof be valid even though that private signal, that private input signal is not known. And that's the whole point of zero-knowledge proofs. We prove that we know a set of signals that satisfy a specific arithmetic circuit. And each set of signals is called a witness. So for our circuit, a valid witness would be 2, 2, and 5 with the output of 20. An invalid witness would be any random number like 1, -3, 12 equals 20. Within that witness, which is basically a set of those signals, some of those values are oftentimes private. So as long as we prove that we know the set of signals surrounding the private signal, then the zero-knowledge proof is valid. Cool. So that's your introduction to the project. So now I'm going to demo the zk proof. What's up, guys? So this is the arithmetic circuit that we built. you can see there are two templates, multiplier 2 and multiplier 3. This circuit multiplies 3 inputs, this one does 2. And there's a more detailed code description in bio like I talked about, but from a high level, essentially the 3 inputs are multiplied together for the output. And the entire premise of this circuit is to have a public value and to prove that we know the 3 input values, which are just 3 factors that multiply together to get to that public value, without revealing what those 3 input values are. I can walk you through some of the files here. So in this input JSON file, we have the 3 input values that we're going to input, which are private. And then in this public file, we have a JSON file containing the output, which is 20. And you can clearly see that 3 input values multiplied together equal the output value. To prove this zkSNARK, there is this proof.json file with a few values, and there's also this solidity file, which is a smart contract consisting of the zero knowledge proof. And if we wanted to use the smart contract to prove this, then we could. However, for this demo, we're not going to use the smart contract. We're just going to prove it in the terminal here. Finally, here we have a JavaScript witness calculator, which you can see is used for calculating witnesses. We have our input values, we have our public output. Now, let's prove that we know these input values, these private signals, these input signals, without actually showing them. So we're going to run this SnarkJS groth16, which is the type of the zero knowledge proof that we're using, zkSNARK, and I've delineated that in the article. So again, plugged again, go check it out. So we're going to call the verification key file. This is a JSON file that comes with the Circom library for any sort of verification. We have our public.json. This takes our output value, the public output value, and checks if it matches with the public output value in the circuit, and also checks that the constraints work with it. Next, we have our proof.json. So here we're taking the proof, checking that the proof matches the public value and that the circuit is in fact true. Okay, so let's run this. Bang, okay. So interesting, the proof is valid. If the proof is valid and the signals that are inputted match the public output, then we have a valid proof, and you can see here that SnarkJS says okay, meaning it's valid. But what would happen if we were to change the public output to be, say, 21, with the same input signals, so clearly they shouldn't match? We run the same code to verify this proof, and what happens? So we get an invalid proof as the output. This clearly validates the 3 important characteristics of a zero knowledge proof. Completeness. So if the zero knowledge proof is accurate and valid, we have okay, meaning that the proof is valid. If the zero knowledge proof is not valid, that means that you have an invalid proof, so soundness, completeness, and soundness. And the last one, zero knowledgeness, which is clearly shown by the way the code is set up. Dope. So we're through with the demo. That was really fun in my opinion. I learned a ton. I hope you did too. And I'd love some feedback on, if this was too hard to follow, too easy to follow, too slow, too quick. I'm still learning on how to make these videos, and I had a lot of fun learning about the process. And I hope this inspired you to get involved with ZK proofs. They're super complicated. Try to dumb it down a little bit, make it simple, easy to understand. And I hope you understand their applications within cybersecurity, within blockchain, and how useful they can be on the Ethereum blockchain specifically because of the way that the snarks are set up. It was super cool to learn about things like the groth16 snarks and the powers of Tau ceremonies, which are just more delineated in the article, which I keep alluding to. And with that, I'm going to say check out the description. I'll have the article that I keep alluding to because it's basically a more in-depth version of this video. I'll have some more resources for ZK if you want to get into it. I will also have my monthly newsletter. Go check that out. See what I've been up to. See what I'm going to be up to in the future. And my portfolio for whatever projects I'm interested in, whether it be blockchain, ZK, climate, or whatever else I get my hands onto. With that, I'll say thank you. Let me know feedback. And if you want to talk, book a call with me. That's what's up. Thank you. See ya.